Welcome back, everybody. I hope you had a nice break, and we're going to start our next panel, which is our industry panel. I see that Josh Holland from Flex has joined us, but it appears that we may be having some challenges with Jack Nalig. So we're going to replace him with Kirk Anderson from Nidec Motor Corporation, just so that we can continue the summit. And if Jack joins us, we'll be glad to have him and his Phoenix contact perspective. So Josh, thank you for joining us. We're really excited that you were able to join us for this presentation today. Why don't you take a minute and just give us a brief introduction of yourself and Flex?
Sure. So I apologize. I don't have slides to share with the team today. I am happy to join and participate in the panel. As most of you know, Flex is a very large multinational contract manufacturer. We offer a lot of different design services. We had presented recently at the NEMA presentation on electrification. We break our organization into two main segments. The first one being a reliability segment that focuses on industries that are heavily regulated, longer life cycles, such as medical, automotive, and industrial. And the second being the agility segment, which focuses on businesses that are a little higher turn. And the areas that they focus on are consumer products, cloud enterprise computing, and also in home and lifestyle products. My particular segment is in the industrial core industrials group. We are a very diversified industrials manufacturer, and that's why we're so close to the NEMA industry. We focus largely around EV charging, electrification applications, and robotics applications from an engineering design perspective, but overall from a manufacturing and support perspective, we really have a very broad market base. So that's my perspective on this, and I do a lot of work both with the engineering design as well as the operations and the manufacturing components of this. My particular role in Flex is I am leading our engineering design as well as our what we call global product launch team, helping take designs from early stage and concept all the way into the manufacturing operations part of the life cycle.
Thanks, Josh. And so I still see that Jack hasn't joined us, so I'll invite Kirk Anderson in and have him introduce himself and Nidec Motor Corporation. I know many of the NEMA members may know Kirk from his previous association with NEMA, and we're glad that you were able to join us today, Kirk.
Oh, good morning, everybody. I wasn't expecting this honor, so thank you for that. I think I've been at Nidec for just over 3 weeks, so this is 3 weeks in one day, learning a lot about it. But what I've learned since I've joined Nidec is that it's a much broader company in this space than I originally thought. So one of the taglines is, if it spins or moves, we have a solution for it. And when you think about advanced manufacturing, Josh, you mentioned robotics. This is really a key part, additional automation. And and motors really drives all this advanced manufacturing. So, whether it's putting chips on circuit boards, there's movement involved. And so, connecting all those machines together, turning electricity into movement, that's what it's all about. So super happy to be here. And Josh, I was really impressed with you at the NEMA annual meeting. So it's a pleasure to share the virtual stage with you.
Yeah, it's a very different experience when you're presenting from your home office than when you're presenting in front of a crowd. It's a little bit more, I think, energizing and fun in front of a crowd.
Energizing is the word that I would use.
I would agree with that. And Josh, don't worry about not having slides. I really would love this to be a conversation between the three of us. And if anybody on the call wants to raise their hand and join the conversation, I think we would all welcome that additional interaction that we don't get because we're not in front of a crowd, but certainly we have a lot of great minds on the call. So I'll start by throwing you a softball question, which is, what does advanced manufacturing mean for you and your company?
So I can start with that. And Flex has obviously a lot of manufacturing facilities, and we consider developing and improving manufacturing capabilities to be a big part of our growth. And what we can differentiate ourselves with. The first part, though, for us is really picking what are the places that make the most sense. So from a Flex perspective, places we put heavy investment in advanced manufacturing engineering is really 4 locations. The first one is advanced simulation of factories, using computer models to simulate the factories before we actually create the factory. So we can simulate the flow, simulate the product build process. We can simulate the types of yields and challenges we're going to have. Our advanced manufacturing engineering team, which is led by a gentleman named Murad Kora, does a fantastic job of that. The second area from an advanced manufacturing perspective is clearly the robotics piece. When I mentioned robotics earlier, that's from my point of view as a segment and helping to develop robotics solutions for our customers. Murad Kora's team in our advanced manufacturing group also leads a very large team that does automation of our factories. And that can be anything from automating the actual build process, think 6-axis or SCARA robotics. It could be things like autonomous mobile robotics that move through the factory and remove some of the material handling components. And it could be, even more deeper, fully automated lines that do processes that humans just can't do. So that's the second leg of our advanced manufacturing platforms. The third leg that we really put a heavy investment in is the additive manufacturing or 3D printing space. Obviously, that space is both been growing and shrinking and growing and shrinking at different points in times through the last few years. However, I think that's a big place for future ways to look at advanced manufacturing and creating parts that couldn't be invented otherwise. And then I'll touch back just for one last time on the idea that electrification has become a big part of our advanced manufacturing footprint. Looking for sustainable solutions for our factories. Flex has been an industry leader in that aspect as well. So those are the places we've put a heavy investment in growing our factories. And really, the secret to a lot of that is linking the whole thing together, and getting those 4 different areas to work as one is a big part of what we can help ourselves differentiate with. Can you guys hear me okay, Megan? Oh, I think you're on mute.
Yep, I was on mute. I'm sorry. I like to talk to myself. I think we've all done that throughout the course of working from home. It looks like we may have temporarily lost Kirk, so I'm going to go on and have this conversation with you. And I think, we heard from Ann Driscoll that the Biden administration understands that workforce development needs are a challenge in U.S. manufacturing. What do you think are some of the key workforce development needs for ensuring that the U.S. can both produce advanced manufacturing systems and utilize them in U.S. manufacturing?
Okay, so that's a really great question. I think there's 2 parts. The first part is developing the workforce to really shift from that sort of traditional manufacturing role into more of this advanced manufacturing, leveraging robotics, repetitive tasks, looking at things and trying to eliminate the muda or the waste that's a part of it is a big component of this. Some of it is just simply a component of making sure that we can find the right folks and find the right people to do these jobs. So I really believe that industry and companies need to partner with local education sources and really train the next generation of folks who are going to come through and perform these tasks, create these robotic solutions, create these, really truly linked and integrated factories, the future factories that we're going to need. And this is going to be an absolute big, important part for, I don't know how international this crowd is. I'm sure every country is dealing with the same labor shortage issues that we're really coming across in the United States. So these tools are the ways to maximize the people and the labor that we do have a part of that. But from a development perspective, I think we have an obligation to train the next generation of folks who are growing into these roles, as well as to partner with the universities and the education systems that's bringing these people into the fold. We're driving the technology, driving the real actual applications, and they're driving the ability to interact and work with those people.
So Josh, I'm not sure how much of this morning sessions that you heard, that NEMA is working with the International Trade Administration on an award, and our focus is to see if we can increase U.S. participation and engagement in international standards. And I'd like to hear your perspective on, one, what are some standards gaps that exist for advanced manufacturing systems, with the acknowledgement that we could have 1 million standards for advanced manufacturing systems, when from the smallest component to the entire system. And two, what are some of the barriers to increasing U.S. participation in those international standards programs?
International standards is going to be such a big part of this. The interoperability of system from component to component is huge. One of the things that we've done a lot of work on is developing connected building blocks for just the communication protocols from one piece of equipment to the next. I think that's a huge place that standards can play a role going forward. If you don't have the ability for machines from different suppliers to speak to each other and share their data and share their communication, the whole system breaks down right from the get-go. So I think the standards component of it is really what will enable a true Industry 4.0 conversion and the advanced manufacturing type tools that we're looking for. So for sure, standard setting is a big part of it. The secondary challenge to that is really the international nature and the difference of requirements from group to group. And I'd love to see especially the safety components standards be the top of the list, because when you talk about the ability for advanced manufacturing robotics, the ability for stuff to go autonomous, you're going to have to really rewrite a lot of these safety standards, in my opinion. And that's an opportunity to try to get them as consistent internationally as humanly possible.
Yeah, and I think that's, if you kind of pull that thread a little bit, after we get all the standards and we get them correct, then it's a regulatory challenge, especially for safety standards for machinery, right? They're regulated around the world completely differently. OSHA regulates on, risk-based analysis, and they regulate the equipment itself. The Europeans regulate the operation of the equipment, which is slightly different, and that makes international safety standards a particularly large challenge. So Kirk, thanks for joining us again. Computer problems are always a challenge in these virtual environments, and I'm glad you were able to figure yours out quickly. The question that I asked Josh that I'd like to throw to you as well is, what are some of the gaps in international standardization, and what are some of the biggest challenges in getting U.S. experts at the table in these international standards discussions?
But so one of the things that I've seen is we talked about data. I think our earlier speaker, spoke about how important data is with Industry 4.0 and advanced manufacturing, and this concept of data or communication. And Josh, you alluded to this. Kind of passing along that information. So one of the issues that I've seen is we have these great technologies and great products, but they're not communicating. So it's almost like an organization of individuals, and because they're not, in a lot of cases, we'll say the base layer of communication hasn't been established yet. What data do you send? How is it encoded? How can we take that information and pass it along in a meaningful way to the person upstream and downstream, so that when you have a supply chain disruption, that you could actually route and figure out where that product is being first sourced and where a true alternate source is. So what we saw during the pandemic was, I have 3 sources, but it was really 3 distributors from one source, and people didn't have the resiliency or the redundancy that they thought they did. And so that's because of a lack of communication throughout the supply chain. So I think in standards, as Josh pointed out, having those groups actually interconnect and start having those dialogues. And so that's kind of the human element of this. And one of the things that also I've seen with the smart manufacturing standards wise is that it has been largely focused on the technologies in that space. So, whether it's a robotics, and I think the answer is, in a lot of cases, it lies with the end user and how the end user wants to use that equipment. And I think that that's a part that still needs to be built out a bit. And then one of the challenges that we have, and this, again, our earlier speaker touched on this. One of the challenges is, the U.S. companies and the U.S. environment for standards development is quite different than compared to, say, Germany or China, where there's this robust bench of people that want to get involved, and many of them have less birthdays than the three of us, and that they're hungry to get in this space. And in the U.S., people look at standards as a four-letter word or some something less than exciting. I think on a previous call, it's almost this masochistic, view of what standards is like, and it's not, but it doesn't have the as much appeal as some of the other careers. And so, kind of helping people see that being involved in standards really allows you to influence the direction of the United States or the world or a whole industry. But that's kind of been buried in some of the less exciting things that we do from time to time, like have committee meetings and have team call breakdowns. So
I'll say after, more than 20 years working in standards development, it definitely doesn't come off as the most exciting thing in the world. But I can tell you, throughout all that experience in a bunch of different industries, standards really do make the world go round, and they touch every part of your life, and they're so, so important. And I'm going to pivot a bit and invite Tim Duffy from Rockwell Automation to join us, because I feel like there's one thing that we forget often when we talk about standards, and that's standard sister conformity assessment. And it's great to have any number of standards that exist, but without being able to show that the tests are repeatable and that the products are actually meeting the standards, what point is it to have the standards at all? So, Tim, I wanted to ask you whether you had any insights into what does the future look like for conformity assessment and advanced manufacturing systems, whether it's in the near, mid, or long term?
That's a really good question. And conformity assessment and standards are all, obviously interrelated. It's one of the challenges in the writing of standards is what's the purpose in writing the standards? It's like, well, hopefully in the end, there's some type of conformity assessment or some evaluation of compliance to that standard. If there isn't that activity or that desire, whether it's done by an individual or a third party, it does raise the question of what's the intent of the standardization. So relative to where do we see conformity assessment going in the future? There's a whole bunch of different aspects that you can bring into this. Some of it is you could ask another question: what is the potential role of blockchain in standards and conformity assessment? Pivoted into a different area, into newer technologies, and to look at it. I don't have the answer to that. I don't know that people have fully analyzed the possibility of using something like a blockchain to document compliance to various standards. Obviously, from a standards perspective, the discussions are ongoing relative to digitization, right, or digitalization of standards, and what does that mean, and how do I take a digital standard and demonstrate some type of compliance? That part is going to be a little more difficult to look at it and say, okay, I have machine readable standards, and now I have a machine that's looked at it and it's semi-self-aware or whatever, but it declares its compliance based on what it's read. That'll be a challenge in the future. But as you start to look at more and more interconnected systems, and we're seeing more and more of this in the industrial space. Devices are more and more of our devices are smarter and smarter. And what all of this leads to is, and I think Kirk mentioned it, is big data. And there's a lot of data and really big data. And where do standards and conformity assessment fit into that data? And then we can take it kind of back to the original part of the kind of commissioning of a system. And you look at, the assembly of that system and the testing of that system pre-commissioning. The smarter and smarter devices allow you to embed information into the device relative to its compliance with either various standards or various regulations or whatever. Imagine being able to turn your system on, very similar to what you do with your computer. You connect a bunch of USB devices, you turn your system on, it tells you what devices are connected. Take it a step further and say, all right, now I've got this complex system. Tell me or give me a report that shows me my compliance with functional safety aspects, hazardous chemical aspects, traditional electrical safety aspects, cybersecurity aspects. You can communicate all of this information as you move forward with smarter devices and smarter standards and incorporation of all of this together. And I see John Callan put a question in about compliance being not a static condition, but extending over the entire lifespan. And certainly that is true for certain aspects. Some aspects relative to compliance based on the regulatory requirements may only require that at the installation your product complies with this, as an example, restriction on hazardous substance regulation. So it's installed and I comply with that. Obviously, I can't change the chemical makeup. So in that case, it is a static condition and a condition at a point in time. But there are other aspects, as I said, as you get to the smarter devices, you can potentially incorporate a risk management related to a functional safety or a risk management related to cybersecurity, where you are continually reporting compliance with certain aspects over the life cycle of that equipment. So I raised a whole bunch of different things there. I don't know that I answered your question, Megan, but
You answered that question in about 10 more, so that's fantastic.
Okay.
Can I just add a little bit in the spirit of sort of conversation? I think, I brought up previously their core building blocks that we're trying to build out for advanced manufacturing engineering. And I think, Tim, you brought up a really fantastic one, which is what's the impact of blockchain technology and that ability to actually go one-to-one with each of the individual components you're producing. I think from a traceability perspective, from an ability to link system to system to know what parts of the process your product has seen, that's going to be the next big frontier, and really accessing that true big data component to manufacturing that's been happening. And blockchain's ability to securely link that from part to part is going to give us the ultimate in traceability. We have not really started that journey quite as far as I'd like to personally go, but I think you nailed it. That's one of the real advanced technologies we all better be looking for.
Well, that blockchain would help with as regulations. I think Megan, you touched on regulations. So once you know that we'll call it an asset or an aspect or a characteristic is now being tracked, you can go ahead and make those updates and it can carry through with the blockchain, and basically you have a living certification or living compliance or aspects that you can't get today, because once it's out there, tracking it down can be almost impossible.
Yeah, true traceability.
So before we dig into digitalization and traceability, I see one more question about standards from the Slido Q&A, and I think this is a good one. The question is, to what extent is this program tapping into the broad range of manufacturing standards that already exist? For example, MT Connect, ISO Step, Working Group 8. And I'm going to sort of shift the question a little bit, which is obviously no one organization can know all there is to know about all of the standards in the advanced manufacturing space. So what are some things that you think NEMA and its members should and can be doing to ensure that as we build a standard strategy for advanced manufacturing, we're acknowledging and taking into account those standards that already exist that we may be able to leverage in achieving our goals?
Josh, do you want to you want to take the lead, or oh, you're on mute.
Okay, so that's a big question. I think that it starts with really there has to be some type of a discussion about what those standards for the data and all that's going to be. I think that's going to be the first and most important aspect of that, because again, I get back to different manufacturers, different regions. How do you link that? How do you actually connect those? So I think that's a big part of it. The second component to that then would be, I think there's going to have to be a discussion, and I start with discussions because somebody has to drive some of these. It's really that new as to what gets done with any of that information that gets captured. Where does it get stored? Where is the repository for that information? Right now, all of that is behind the scenes as well. So that's why I said this is really at its infancy stage as far as it goes. And I think that if there was some type of standard, companies would rally to that because we're looking for something. And the last thing you want to do is you want to end up creating the Betamax version of the process. You don't want to be the one who you've created this wonderful system and doesn't partner and interact with other suppliers. So driving that early and an organization like NEMA helping to drive and set that standard, I think really helps.
And I hate to tell you, Josh, as somebody that worked in consumer electronics, Betamax was a standard as well, even though it was a failed one ultimately.
but that's my point, is companies want to be careful that they're investing in the right spot for sure.
Yeah. Tim or Kirk, did you have anything to add to that, to Josh's answer about kind of the standards landscape?
I'll let you go, Tim, and then I'll put in
Yeah,
my ones.
I think the first thing to look at, based on your question, is from a standard strategy standpoint, is to ask the question: do we have a standard strategy that has identified all of the areas of concern, or at least the major areas of concern? And John's been posting a bunch of things in the chat where I think my question about do we have a standard strategy kind of relates to John Callan's question about NEMA creating an overview map of manufacturing systems that identify different domains that are being standardized, where those exist, what's our roadmap. And some of that work relative to road mapping and so on is certainly being done in the IEC within the systems committee on smart manufacturing. And we used to have some people that participated in that. I know Rockwell has some people that participated in that. But it does raise the question about where's the roadmap, where's the strategy, how can we identify our participation strategy if we don't know what the roadmap is and where we're going. And I think the participation strategy is a huge one. We have to look at it, and obviously that's one of the major aspects of the grant is how do we increase that U.S. participation in certain of these areas, and increasing the participation where it makes sense. And we have to in many cases, limit our resources. We put them in the areas that make the most sense and have the biggest impact. How can we get the biggest bang for our buck? So I'll leave it there. And Kirk?
Well, I give this a little bit of thought, given Josh and Tim. And here's some observations. One, as I researched this topic of smart and advanced manufacturing, what I found is, in a lot of cases, for a given industry or a given area, there's only maybe one or two associations that are reflective of that group. When you type in smart manufacturing or advanced manufacturing, you'll find a dozen associations that are leading in this area. And I think that creates a potential fragmentation where everybody's trying to do something. And you can get a sense of that, at least here in the US. NIST created a landscape document a couple years ago. And if you look at the Japanese and the French and the Chinese and Europe, their Industry 4.0 advanced manufacturing usually looks like a nice grid, and everything is layered and boxed, and it's nice and organized, and it looks like my desk doesn't look like. And then when you go ahead and look at the NIST model, it looks like chutes and ladders. It's got arrows going this way and that way, and it's indecipherable. But I think that's closer to the reality, is that there's a lot of activity going on. It's not coordinated. It's sporadic. And that's, I mean, in a lot of cases, advanced things, cutting edge things aren't organized. They kind of grow in, spurts and jumps. So I think NEMA can help being a rally point of saying, look, we have this great technology here. We have opportunities, public-private partnerships here. We have government interest here. We have MDCP. We have ITA. We have commerce. We have all these groups. Can we get the business people together and start to organize and say, look, this group needs to catch up a little bit. Here's where a standard is necessary. Here's where a business case needs to be fleshed out. Here's where we need to maybe talk to USTR or Commerce or WTO or someone else to help even out that playing field. But right now, there's just a lot of great stuff, but it hasn't been built into. Josh, you talked about pieces, and I think I imagine these Lego pieces. We have them all dumped out, but we haven't built it into this, factory of the future. So, sorry, everybody who's worked with me knows I love analogies, so I had to throw at least 3 of them in.
I'll add to that. I think, I'm a big believer, coming from the engineering product development world, in prototyping. And I think there's a lot of opportunities to prototype some of these technologies, and the World Economic Forum's Global Lighthouse Network is a great opportunity to test case some of these things. And really, that's what's going to take when you have so many complicated standards trying to come together, and communication protocols and all of that. I think we're going to need to sponsor prototyping a few things. And I think that's one of the very key steps in this process, just like any product development process. Get it out there, put it in the field, try it, learn what does and doesn't work, and then build off of that. I think that's going to be a part of this as things go forward.
I think you also have to look at whether or not that prototyping involves something like digital twinning. Do we need to develop the prototypes in actual physical locations? And, probably not. I think there's a lot of ability to utilize some of that advanced technology related to digital twins and running those in a digital environment and analyzing certain things.
So I'm just going to jump in and say one word about standard strategy, because it came up amongst, I think, all 3 of you and in some of the questions. Certainly as part of this award, NEMA does intend to try to develop and maintain a standard strategy for advanced manufacturing. And Josh, you mentioned way back in the very beginning of the remarks in this session, additive manufacturing. And I'm sure you're aware of the collaborative between the American National Standards Institute and America Makes, which ended up in the development of, I think, what is a really elegant standards roadmap for additive manufacturing. And we'll probably use that sort of as a template as we consider what that roadmap and strategy looks like for additive manufacturing. And I want to shift again, just because I love to throw some more surprises in, and ask Lou Grice, who is the VP for Digitalization at Phoenix Contact, to join us and ask him about what are the enabling technologies that are indispensable for manufacturers to adopt today as we prepare to continue increasing automation and digitization in manufacturing across the US and the globe.
Hi, everyone.
So,
Thanks.
Lou?
Can y'all hear me okay?
Absolutely.
Okay, good. Yeah, that's a good one. And I'm glad you phrased it as enablers, because I think, from a digitalization standpoint, you talk about digital transformation, there are a couple views you can take. Unfortunately, I think in digitalization, that technology tends to take the limelight relative to, I got something done in making a digital transformation happen. So what that means is that you put the applications or the categories of the business kind of above what the enablers might be, and then you pick and choose your salad bar of technologies to make that application work, whether it's the digitalization of a process, whether it's the development of a digital twin, whether it's a new product, a new service, a new software, so on and so forth. So the question being, then what are those elements or technologies that probably are fundamental? It probably does. The first question, probably the fundamental question of digitalization, settles in on a lot of what you guys have been discussing, which is that data mindedness and answering a whole lot of questions about the data you're seeking to use. How are you, maybe one of the most important being, how are you contextualizing it? What information models are you using? What forms of metadata are you using to describe what the data is? Data about data is essentially how you contextualize it. That's the number one. And then, figuring out the suite of corresponding technologies for making that data useful, including the network, including the storage, including the processing power and where you need it at the edge or in the cloud, including the analytics, so on and so forth. It's so foundational that, you can actually grow that as from, your thought process as a root, beginning with the data and then moving upwards beyond that. Industry 4.0 then introduces all sorts of crazy ideas to it, which is, I don't have to isolate my data to, a particular level of the factory floor. It might be usable or useful further upstream. If you're using, the old layered Purdue models or whatnot, you might find that data literally produced, in first principle engineering, temperature or vibration, might be really useful all the way up in the cloud for analytics purposes. And I don't make that claim lightly. I make that claim in light of, developments like Amazon Web Services Monotron product, for instance. So that's probably fundamental. Clearly in today's day and age of, bad actors, cybersecurity has to be brought more front of mind. So you have to figure out at some point, how I'm going to manage that. There are lots of different paradigms. There are lots of different weird psychologies and players and bad actors that you have to worry about. Zero trust being a paradigm that you might have to adopt to make it happen. And there's all sorts of, weird methods that, in the classic manufacturing world where I just got to get data from point A to point B. Now all of a sudden you have to think of things like honeypots and diversions and instances where you find anomalies and things along those lines. So the cybersecurity issue is definitely absolutely top of mind. Another element I would say to it is that when you look at young folks getting into the industry, they grow up in development environments that are different from, the classic, how we handle data at the factory floor level. They grow up in different development environments, and that's part of the challenge is how do you use what they know how to do in Python or in MATLAB or C+. How do you get them to the point where they can use that know-how, that power of coming to understand what those programming and development capabilities are down to the factory floor level? So you have to put that into consideration and think about, what does your automation and control environment have to offer them, when it comes to that kind of thing. So what that really means is that digital transformation, digitalization really isn't just about the technologies, it's about the practitioners of the technologies. And you have to have a clear insight as to, how best to introduce them into the space, the 5D space of the factory floor, the dark, dirty, damp, demeaning, all those levels of how you might consider the factory floor. So I don't know if that answers, that's probably a long answer to a short question, but hopefully that gets you somewhere down the line there.
You're on mute, Megan.
Always. Thanks, Lou, for that great insight. Josh and Kirk, did you have anything to add to Lou's comments about digitalization?
I was just going to add, I think Lou brought up a really good point, which is from any digitization effort, and we've done a few of them, the first is begin with the end in mind. What do you want to do with that data that you're gathering? And I think from a fundamentals, I think that's the big building block that you hit on is, okay, so I'm going to get all this information. What do I want to do with it? What do I want to do after I got it? How do I protect it from a cybersecurity perspective? These are really fundamental building blocks that have to be considered before you start collecting the data. And then I love that you brought up the sort of the idea of object-oriented programming and Python and some of these tools that are coming out with some of the optics and visualization methodologies that are out there. I mean, we're going to be collecting data from autonomous robots that are taking pictures of things as it's riding through our factory in the future. It's not going to be that very obvious temperature, humidity, data that we've collected in the past from IoT connected devices. We're going to have a camera going through our facility, surveying inventory and surveying what steps in the process this stuff is at. And object-oriented programming is going to be a basis for that. So I miss that as one of the really early fundamentals that we've got to develop as we work with the next generation of manufacturing engineering leads. I think that's a really big problem, is finding people who are capable of helping translate that vision of what we're going to do with the data at the end into a final solution for the product.
I'll just emphasize what Josh and others have said is start with the end in mind. Data to collect data isn't going to yield that. You'll have a big mound of data, but you won't be able to get any insight. So, and that's why I think it's so important to get the entire supply chain or the end user in mind, because a lot of the technologies being built, yes, you can do all these things, but if the end user doesn't know how to use it or doesn't know what that's capable of, it's kind of a feature that can't be leveraged. So great insights.
All right, I'm going to pivot once again. NEMA has spent a lot of time over the past several months looking into and discussing the Infrastructure Investment and Jobs Act, which I'll just call the Infrastructure Act for now. How do you see this act affecting the adoption of advanced manufacturing? Do you think that it will renew interest and expand domestic manufacturing? And in doing so, will it be a bigger driver for implementation of advanced manufacturing systems?
Kirk, did you want to go first on this one? Or you want me to jump in there?
Sure. So my hope is that this helps. The Biden administration has highlighted that they want to have a lot of the money go towards this Buy American concept, and the implementation of that remains to be seen. But there's this push to rebuild the manufacturing base here in the United States. And it makes sense if you're going to go ahead and rebuild it, just as we're thinking about rethinking how the transportation sector, electrify. We're now looking at port electrification. We're looking at electrification in all these different spaces. Taking what we know now and going back to this start with the end in mind. What can we do, or what should we be thinking when we're building this now that we have this technology? I liken it to tragedy, but opportunity. Think about how Japan was able to take advantage of adopting the latest manufacturing techniques after World War II. Think about how China went to better communications, even though the U.S. started a little bit earlier. And so you just think about, well, here's a chance for us to reinvest in key areas using advanced manufacturing. So if we're going to build it here, let's build it using the best tools.
Yeah, so expanding a little bit on that from a perspective of a very large manufacturer that has a diversified global footprint, I think one of the things that it really does, and this will link back a little bit to what we talked about in the electrification forum too, one of the things that this type of an act or this type of an investment does is it really gives us an opportunity to go and try something that maybe wouldn't have the ROI on paper that is typically considered. And I think that creates that momentum for getting some of these initiatives started. So I do think that it's going to be a benefit. I do think it's very important that we invest in that infrastructure of manufacturing and train that next generation of folks into manufacturing and make it a career that's not Lou, I don't like the picture you painted of the dark and dank factory. I want it to be that sort of next generation place that people are excited to go to. And I think that's the very big key to making this an exciting career for folks. And this type of an act or investment can put cutting edge technology back into the factory. Because again, I think that all of these challenges of finding the right workforce and the reaction time and access to the data, all of that, this can be a springboard into investing in some of that. And so we track very closely what the exactly, I agree, John, dark and dank are misrepresentations. I started my career in a cast iron foundry. I know what those look like. But this could be a springboard into the next generation of that. And I think that's what gets people excited about investing technologies in this. And I think that the robotics and the automation and the optical components that are being built into these things are going to be things that we hadn't even considered a possibility for collecting data and monetizing and utilizing that data going forward.
Tim or Lou, do you have anything to add to Josh and Kirk's comments?
So I guess I'd offer relative to the infrastructure bill, there's a couple of different things that having looked at some of the opportunities and, NEMA's kind of done a first cut analysis at what's in there. And you look at it and you say, well, gee, there's, trillions in there. And let's break those down. What's available for NEMA members? Where does a lot of this trillions go? And you end up finding rather quickly that it goes to states, goes to municipalities. There are some wider areas for improvement. You look at a general search on airports. Kirk mentioned port electrification. There's things like that in there. But I think from a NEMA perspective, the first thing that we have to do is a kind of a deeper dive on where are the opportunities, where do those exist, how do we identify at what level they are. So if you have a federal agency that's distributing this money down to the states or down to the specific municipalities, how do we take advantage of some of those opportunities? Some of what I've seen in there, there are some carve outs for reshoring, right shoring, whatever you want to call it. Those are awesome things. You look at Intel's recent announcement about their chip fab plant in I believe it's in Columbus. Things like that. That's the kind of stuff that you want to see. It'd be interesting to see if some of what Intel is proposing is potentially taking advantage of some of that infrastructure, some of those infrastructure funds and resources. Finally, one of the other main areas in the infrastructure bill that provides some opportunities that we have to look at is kind of in the system efficiency gains. There's as you get down to the money that's doled out to a municipality for its water and wastewater treatment plants, how do we take advantage of that? And so for somebody like a Rockwell Automation, is that one of my direct? Is that where I can get a direct benefit, or is it a second tier where I supply to the customer and they take advantage of it? So it's kind of analyzing from an individual company, is that a first tier, second tier, or third tier opportunity? And I think that's important for us as NEMA members to see where those opportunities are and kind of focus in on those and use the resources of NEMA to assist us in that analysis.
Great. So we have about 6 minutes left in this session before, for those of us on the East Coast, we take what I'll call a lunch break. And for everybody else, it's just a break to check your email or stretch your legs. And I think what I'd like to ask Tim and Josh and Kirk and Lou and really anybody on the line is, what questions do you have for each other or for NEMA or for ITA?
I'll throw a fun one out there for everybody as we talk about, sort of next generation technologies. We all like to be a little bit of futurists. One of the areas that's a particular interest for me is, how does augmented reality and some of these new technologies that are being platformed fit into our view of future advanced manufacturing engineering? I know Flex has made some early investments in trying to pioneer some of that, but we really haven't found the sweet spot. And so with a forum like this, I just love asking people futurist questions. So I'll throw that out there to my fellow panelists and see what you guys think.
Yeah, I think the ARXR field is something that is really interesting, and something where we have to look at it from advanced manufacturing and the opportunities it may provide. It ranges anywhere from some of that digital twinning. All right, you couple that with NEXR, and now you're immersed inside of your machine, and you're able to look at various aspects of it. It has so many opportunities as well from a servicing perspective. And I forget if it was Lou that mentioned the flying in either with a drone or cameras or something, checking on the status of different things. ARXR provides that opportunity to utilize some of that technology to go onto the plant floor where previously you didn't have that opportunity to get that either visual experience or visual coupled with additional instrumentation providing you with the data, having all of that come up right on your eyes at a remote location in order to do that. You're already seeing a lot of this stuff with augmented reality in assisting in the servicing of some of the systems that are out there. Sky's the limit. Take it where you want with a lot of this stuff. It's some real interesting opportunities.
Yeah, my sense of it is exactly that it'll probably, or it has the prospects of becoming a foundational technology, much the same way computing did. It from the standpoint of, if you abstract one layer of what it's helping people get done, is those knowledgeable actors don't have each other anymore. when you look at what AR can accomplish, and a lot of this was amplified during the pandemic, when you look at what it can accomplish with supporting experts that are remote to the actual engagement with a device or factory machine or something like that, through some type of headset that a tech that might not have the level of expertise, either repairing the machine or actually, constructing the machine and commissioning the machine, that remote expertise aspect, plus the fact that from a knowledge management standpoint, you can flow into the device, the whole host of documentation, instructions, step-by-steps, whatever you might need to make that knowledge flow at the moment when it's necessary. You really reduce, I guess you would call it like a cognitive dissonance between somebody trying to find the manual first, look up the page where it is, make sure that that matches the pictures, what's shown matches what the machine shows, on and on. All that goes away, gone. And technologies like augmented realities and virtual realities can really establish a new paradigm for operating inside that factory environment, from a training standpoint, from a knowledge sharing standpoint, from a knowledge transfer standpoint. Older folks retiring, newer folks coming in. What do I do step by step to get this process up and running, or repair this machine, or something along those lines? To Tim's point, the use cases are use your imagination. From auditing standpoint, just use your imagination. There's an amazing array of things that can be done with it. So it may well just be foundational for one of the foundational technologies beyond computing for what the smart factory means.
I have just a 30-second plug. If there is value in smart manufacturing, encourage everybody to think about joining the SYC-SM committee on smart manufacturing, which I'm the TA for. So, we're trying to shift it away from just technical work and standards for the sake of standards, but really trying to link together, what Lou and others have talked about, which is we're trying to create solutions, and we need to have that. We need to figure out how to apply those standards, what kind of communication, what kind of information. So you can contact Dave Richmond. I see he's on the call. But if you're interested in helping push that forward, or if you're a leader and you have people in your organization, it's a great way to help this topic move forward step by step.
And I'll help to translate the Kirk acronym soup.
Yeah.
He's talking about the International Electrotechnical Commission, or the IEC, Systems Committee on Smart Manufacturing, SYC-SM, for which he is the technical advisor of the United States Mirror Group, or TAG. So that's a lot of words, and that is to say this is a group internationally that's focused on trying to figure out how to ensure that smart manufacturing is addressed as a system throughout IEC standards, whether they be component standards or bigger. And I see Wally Zoller has added some links into the chat, so feel free to look at that. And if you have any questions, reach out to David Richmond, as Kirk mentioned, or you can reach out to me directly, and I'm happy to put you in touch with David. So we're at 12:01. I would like to thank John Callan for all of his really fantastic questions in the chat, and encourage everybody else to follow John's lead and engage with our speakers and presenters. I would also like to thank Josh and Kirk and Tim and Lou for stepping in and answering some of our hard questions and some of our easy questions. I thought that was a really great panel, and we learned a lot about some of the challenges and opportunities for advanced manufacturing systems. So next we're going to take, like I said, a break. I'll call it a lunch break for those of us on the East Coast. And I've added the slido.com event code for you all. Again, feel free to go and ask any questions. If we don't get to those questions throughout the course of these 2 days, we will try to ensure that we answer them in a report that we'll put out after the event. So thank you, everybody, and we'll see you all back here at 12:30.
Thanks, Megan.
Thanks, everybody.